Welcome to another episode of the Driver's Alert Driving Safety Podcast, where we interview some of the most influential people in driving safety. Our guest today is Mike Branch. He is the Vice President of Data and Analytics at Geotab, the global leader in vehicle telematics technology, recording more than 2 billion events around the world every single day. At Geotab, Mike is responsible for data strategy and innovation, as well as the management of the data engineering, data science, machine learning, and data visualization divisions. No doubt a huge responsibility. Mike is a frequent guest speaker on the subject of connected vehicles, having delivered presentations on topics like the Internet of Things, smart transportation, and big data. Prior to joining the Geotab team, Mike was the founder and CEO of Innovex, a software development company focused on the healthcare and energy sectors. Mike holds an undergraduate degree in computer engineering from the University of Toronto and is currently working on a Master of Management in Artificial Intelligence from Queen's University. Mike, thank you for joining us today.
It's a pleasure to be here, Rich.
Mike, in November, Geotab appeared on Deloitte's Technology Fast 500, which is a ranking of the 500 fastest growing technology, media, telecommunications, life sciences, and energy tech companies in North America. Apparently, this is Geotab's 7th time to make this prestigious list. So first of all, congratulations.
Oh, thank you very much for that. Yeah.
Before we dive into the discussion on big data, would you mind giving our audience just a little overview of what Geotab is?
Yeah, sure thing, Rich. So Geotab's been around since 2000. We are a telematics company. So we have an onboard diagnostic port device. A little device plugs into the OBD port in your vehicle. And we track everything from engine RPM through to seatbelt buckled, unbuckled, believe it or not, windshield wiper activation as well too. And we transmit all this data through the cloud to our platform. And we right now monitor almost 1.4 million commercial vehicles. And these vehicles range from commercial fleets of 1 all the way through to 80,000. And we help our customers out from a fleet safety perspective, from a productivity perspective, compliance, you name it. We've got a rich suite of APIs so you can access all of this data and pump it into your back-end systems. As of late, what we've been doing, what my department specifically has been looking at is how can we leverage all of this data at scale to help out our 35,000 customers and provide them with useful insight from all of this data.
So Geotab is definitely more than just a hardware, and software type company. I mean, you guys are really looking at how to make sense of all of this data and help predict and improve productivity and efficiency.
Yeah, and I think one of the really interesting things is that in this ecosystem that we've built here, everything from the actual device itself through to our analytics and our software applications, everything's done in-house by Geotab. And we see ourselves really now more of a data player, right? So we don't care where we're getting this data from. Actually, we've got our competition sending data through our platform as well too. So we believe in this open ecosystem approach. The phrase cooperation is often used as well too, where this data is just infusing into our platform and we can make sense of it. And that's where we're really leading the way and where we're really experts. Yeah.
And we hear the term big data a lot, and sometimes even I think internally we kind of make fun of it and we laugh at it because sometimes people just throw a term around and it just sounds like, oh, okay, I know what I'm talking about. But everybody knows what data is, but what is the threshold that turns data into big data? What does that really mean?
Geotab. Just picture that one word, Geotab, and if you know Geotab, then you know big data. But in all seriousness, when you think about big data, and you mentioned, we collect about 2 billion records. We're probably close to 3 billion raw records a day. But if you interpolate that to somebody driving in 10 meter by 10 meter segments, we're closer to 30 billion records a day. So at scale, that's a lot of data, and it's figuring out ways to interpret that data, recognizing patterns in the data. And figuring out how you can leverage it to provide insight. That's where big data really does come to play. And if you think about where we are now versus even a few years ago, it's remarkable. We're at a point in time where everything is really just converged. So with hardware, with the software applications that are built on top of it, telecommunications, everything is converged so that I can run a query across our entire data set, billions of records, and expect a reply in seconds. Even just a few years ago, that simply wasn't possible to the scale that it is today. So really exciting to be in this field right now because this is really the foundation for AI, for machine learning, having this solid data infrastructure to work with.
So is I guess maybe a use case. What is a particular example where you could say, hey, here's big data in practice, and here's what it means, and here's what it could do.
Yeah. So for us, I mean, we have a myriad of different examples. As I mentioned, we've got 35,000 customers, but across this base, they vary so much. So we've got folks in the municipal sector, we've got folks in long haul trucking, hub and spoke delivery workers. And for us to really understand what they're doing and provide them with the requisite benchmarks can be difficult, right? So typically what's done in the industry is people will benchmark you based on industry, but that's not necessarily the correct thing to do. We believe it's based on the movement pattern of the vehicle. So if I am a fleet of delivery vehicles operating in the Rocky Mountains, my fuel economy is going to be much different from a fleet of delivery vehicles operating in, say, New York City. And one of the great things is we've got the driving pattern of the vehicle. We know the real world fuel economy of every single vehicle. So I can tell you whether, driving in the Rocky Mountains with a Ford F-150 is better than, say, a GMC Sierra or a Toyota Tacoma or the like. And what we've been able to do with our machine learning algorithms, we're able to add that extra layer on top. So I can tell you whether you're dealing with an office worker vehicle, or whether you're dealing with a hub and spoke delivery vehicle, or you're dealing with a long haul vehicle, or the list goes on. And we do this not by allowing our customers to say that, because if I'm going to scale from 1.4 million vehicles to 2 to 3 to 4 million vehicles, I can't rely on my customer telling me these things. I have to learn it from the data. And so that's a real world example of where we're leveraging big data at scale to provide these benchmarks, customized benchmarks to our customers.
Now, before I'm interested too in how big data relates to a smart city, but before we get into that, what is a smart city? Is there an example today in practice of a city that is smart or is on its way to being a smart city?
So we picked on two different terms there, which are misused across the board. So big data and smart city. And smart city has so many different connotations, right? And so many different meanings. When I think about smart city, though, I think about it as a way of leveraging technology in an intelligent way, usually driven by sensors, to better the lives of people in that city. And things bubble up in and around that. But ultimately, what you're trying to do is you're trying to better the lives of people in that city through the use of technology in an intelligent way.
Okay. And so those two, I guess what you're saying is those two terms, or they do have a relationship, or are they separate? I mean, how do I look at that?
I absolutely think they have a relationship. And to give you kind of a few examples, so as a result of having thousands of vehicles driving around a city, we're able to tell that city now in an intelligent and organic way, different things that they may not have already known. We're able to look at areas in the city where people are slamming on their brakes consistently, and it's a function of the area. Maybe there's a blind rise, maybe a stop sign is missing in an area. And just by identifying these areas, it tells and highlights the city to the fact that, hey, you know what, you've got an issue over here. We may not tell you why, but we'll tell you there's an issue here, and it's through the use, again, of big data. Intersection insights, being able to tell people average wait times at different intersections as a result of the free flow of vehicle data that we have within the city. And again, sometimes it doesn't even take outfitting a municipality's fleet with these devices. It's as a result of all the fleets moving within that municipality, we can glean these insights at aggregate.
And so how does it exactly work? Or does it still require a human being to look at the data or the output and identify areas to flag, or is the system or the software, I guess with the underlying component is the equations, all the modeling that goes into it, is that in essence, really giving you some of the flags or the recommendations? How much human intervention is still required?
Yeah, so I mean, there's still the requirement to kind of look at that data that we have already flagged and make a decision as to, do you want to go and investigate further? Do you want to, what is the intervention you're going to take? But what we do is we categorize those. Let's take hazardous driving areas as an example. We'll categorize the severity of these areas so that it allows the city manager at a glance to be able to zoom into a specific area and look at those high areas where there is a number of hazardous driving areas happening, and then you can take that intervention on your own, right? So we do provide those visualizations, and we're also working with partners whereby they may have their own platform, and we infuse the data behind the scenes as well. Again, this is all one of the important things to realize too, is that it is all aggregate data, right? So we're never identifying an individual customer. Privacy of the data is a huge thing nowadays that we're very, very cognizant of. So all the data that we're working with is all at an aggregate level.
So, for instance, like I'm driving, let's say I'm going to work and I'm looking at, let's say I've got, I've got my phone, not touching it, by the way, no distracted driving,
Yes.
but I can see on the map, I can see whenever there's a problem spot, let's say a stretch of highway where it's slowing down because there's an accident, for instance, and you might have the programs out there that will direct you to reroute around that so that you can find the most efficient way. So this is an example, I would assume, of starting to build that smarter city where you're tying everybody in to this grid so that you're making travel more efficient and trying to route people in the best way possible. Is that an example?
Yeah, that would be certainly an example. One we did with City of Chicago, and some data that we uncovered there is we were interested in what is the effect of weather and traffic flow conditions on the dangerous driving areas within a city. So we did find a correlation between those things, by the way. So when we would decrease the weather to near freezing, we would increase precipitation and decrease visibility and increase traffic flow. Now let's run our model and see where how those areas shift and change. And they did shift and change as well. And we found a couple areas. One I think was near a school, and it was quite kind of revealing. What we were able to find is you put on your little Google Maps guy, right? And you go to the street view and you bring him in and you see, well, what is it about this area that is so hazardous, right? And you look around and you see right around that area, there's bike racks, right? So you've got kids going back and forth all the time during the busy hours of the day. The road conditions were not so hot in that area. And you've got a back alleyway there without a stop sign that goes into the main area. So immediately, if I'm a planner, I look at this area and say, at the very least, let's put a stop sign here, right? So again, it highlights the fact that there is an issue in this area, and we look for persistent issues, right? And then it brings that to the attention of the city so that they can do something about it. I mean, the nice thing is that there's no additional sensor network they need to put in place, right? These are all vehicles that are going about their everyday business, and we're able to develop and devise some solutions that can help the city as a corollary of all of that.
So then with respect to big data, we're not just talking about a volume, just a massive volume of information, but also just a multitude of variables that all have different, percentages, I guess, if you will, of influence on a particular outcome that you're having to make sense of.
Yeah, and we call those things features in machine learning. So what and it really does fall to the quality of the data that you're dealing with. That has to be like number one, right? So you have to understand your data fundamentally very, very well. You have to understand the quality of that data. And once you do, you're able to devise these features, and you can use machine learning to determine, what is the importance of this feature on the model that you're trying to build to predict something? What is the importance of, this drop in temperature? What is the importance of, somebody driving at this particular time of day on your model? So these are things that machine learning can help out with, but I can't underscore enough the importance in creating an ecosystem where the data is of top-notch quality, and your data scientists understand what everything means.
And what is the different underlying technologies. So we're dealing with Wi-Fi, we're dealing with cellular data.
Mhm.
Are there other areas that I'm missing?
Yeah, so I mean, all the data from the Geotab units get transmitted over a cellular network, and that gets transmitted up to our cloud platform or our gateway servers. And then we leverage a ton of technology really in the cloud. And, Google BigQuery has been kind of instrumental in helping us to get to the scale that we need to as well. So on average, by the time the piece of information arrives from our gateway servers to our data and analytics system, it's usually about 5 to 10 seconds. It's even quicker for all of our production servers. But in our data and analytics environment, to have that in 5 to 10 seconds for us to be able to do analysis is pretty remarkable.
Would you say there are some model cities out there right now that are kind of on the pioneering front of adopting some of this technology and actually making some use of it?
Yeah, no, I think there are some. There's no kind of unified, I would say, golden poster child use case. I think different cities are accelerating well in different areas. Singapore is certainly one, and one of the things that I like about the way that Singapore has approached it. Typically, one of the biggest problems in doing something within a city is uh, this whole notion of smart city is still a bit of a new thing, and it takes the officials within the government a while to figure out how do we deal with this phenomenon of new sensor networks and these new projects that need to be created to enable our citizens. So what they've one of the first steps that they did is they looked at educating internally within the government, and creating these educational streams about big data, about smart city, about AI. And as you educate the government officials, it makes the procurement process that much easier because they understand fundamentally what they're looking at adopting within the city. So just those fundamental changes can have such a big impact. We're doing some work with Smart Columbus as well too, and we're infusing some Geotab data into Smart Columbus operating system. So that's been fantastic working with them. Toronto is doing some interesting things as well. So we're really pumped to be working with them as well. But everybody is, there's typically different focus. Sometimes these cities will focus more on a healthcare arena. Sometimes it's more mobility or transportation. Where Geotab tends to fit really well is when cities are looking at mobility or transportation, urban planning type issues, and our data lends itself really well to that.
From a safety perspective, so I guess what I'm hearing is there's at least a couple of angles. One is real time information could be used to help people who are in transit to be more safe, I suppose. And then also to help engineer better roads. Like you said, if you identify a trouble spot, for instance, that's communicated to a municipality, and then
Yeah.
maybe there's a blind corner or for whatever reason, and that helps them engineer out the hazard, if you will. Is there any other angle maybe that I missed there? I mean, in terms of safety.
Yeah, I mean, one of the things that we've looked at, and from a safety perspective, we look at the road design as well too. So we collect as the vehicle is going along the acceleration. So we look at the Z index and the accelerometer, so we can say whether there's potholes within there. What does your road quality index look like? So that's kind of one that has been really big, because what we're able to do is we're able to map out at macro scale, give a city a green, yellow, red, and tell you what does your road quality look like in these areas. And then from a safety perspective and fuel economy perspective, that can make a real big difference. We're doing some interesting things too in vehicle to infrastructure communication. So there's a bit of a safety angle there, I suppose. But as you're coming up on an intersection, if I'm a class 7 or 8 heavy duty truck, and the light's about to turn yellow, let's extend it by green for another 5 to 10 seconds, allow the freight through. So it helps out from an idling perspective, at the light on emissions, fuel economy perspective, eases traffic flow through the corridor to a certain extent. And in my perception also can help from a safety perspective, as this truck is not slamming on the brakes as it's about to hit this intersection. How many times have we been sitting behind one of these class 7 or 8 heavy duty trucks at an intersection? We just wish, couldn't you have just gone through? and it takes them forever to start up again. So those are a couple of things really in pilot phase. We did some interesting work with a company out here called MyoVision in the city of Detroit to create the world's smartest intersection. A few things that have come up lately, I think, on that front that have been interesting.
So I guess a bigger question to tie us all together. What do you think is the end game for all this technology, if there is? Is this eventually going to all get rolled into improving autonomous vehicles and taking the whole driver equation, take that out of the equation altogether? Where is this all going?
I think there's a few different areas that it's going. Autonomous vehicles is certainly one, and people claim that is just around the corner. And in minute, small little pockets, you may have that happening. But for it to become ubiquitously available, I think you're still a ways away. The average age of a vehicle on the road in the U.S. is about 11 years right now. So we're still looking at least that many years in front before people are using technology that's available today. So I think you're still a ways away. All of the mapping data, all of the GPS data recorded from these vehicles, the driver and Geotab devices, anybody with a handheld device, that will all influence, I think, the mapping models that these autonomous vehicles use to navigate the world around them as things shift. So I think that is definitely one core area. I think as well too, it's a huge opportunity for cities. Instead of investing in these massive infrastructure projects to collect some of this data to help them, the data is already out there. Use it, leverage it, be more efficient as a municipality. Here's a super simple example. How these pneumatic tubes that you have on the road and that they track speed and vehicle counts. I'm sure they have them in the U.S. as well too, but I see them all the time out here in Canada. Does it really make sense to be laying these down all the time? Spending a fortune a year just in having somebody go out. I talk to some municipalities and say, you know what, a citizen will call in, complain about speeding in their area. 3 months later, we get around to throwing out the pneumatics tube. A few months after that, we actually get around to doing the analysis on the data. Wouldn't it make sense just to draw a line on a map and be able to have that data fairly instantaneously available to you? And we've done that in certain areas, right? So where you can draw that little line on a map, and we may not have full coverage, but we'll tell you areas where we're relatively confident what those speeds look like on a daily basis. So things like that, I think, allow municipalities to just be smarter, right? So when you talk about smart city, that's a real simple example of leveraging data and partnerships that are already out there.
And as we're looking over on the horizon for Geotab, do you see what's kind of I guess in the works? What's the future look like for the company? You mentioned data. And coming up with better ways to make sense of it and help improve the efficiency of municipalities and safety and so forth. Is it just continuing to move in that direction, or are there any big exciting things around the corner?
I think so. One of the things that was very exciting from this past year is our acquisition of Fleet Karma, so too back in June, and the whole electric vehicle space dovetails really well with this. So when you talk about creating that kind of smart city ecosystem, you have to look at your charging infrastructure as well too. You look at electric vehicle suitability assessments. What's the potential for me to replace my fleet of vehicles with EVs? That's in the works. From an AI perspective, it's really doing more with the volume of data that we have. It's plugging in not only to Geotab devices, but being able to inevitably OEMs will have a lot of this functionality embedded. It's working with the OEMs to capture that data and unify it on a single platform, because you look at, a seatbelt buckled unbuckle event from a Chevy versus a Ford versus a Toyota. They're all different codes. And to normalize that across the board, not a trivial thing. And that's where I think we play a real good really normalizer or equalizer of all of this data across the board. So we will continue to play in the space where we are helping our fleet customers, become more productive, accessibility to data in a private environment, And then the push forward for us is a lot in this kind of smart city domain as well, too, looping in electric vehicles into the mix as well.
Mike, we're coming up on the our time limit. Is there anything else you would like to add before we go?
I think the only other thing I would add is that from a data perspective, I think especially in this world that we live in right now, you have to do things in an ethical way, right? And that is truly a core belief of ours at Geotab is having this ethical approach to leveraging data, whether you're leveraging data for good and equipping, we've equipped our devices with air quality sensors to be able to map out hyper-local air quality. Our privacy standards are kind of top notch, and then we never disclose any private information. But there's always that mix between kind of data utility and data privacy, and finding that balance is very very challenging. But I think data ethics is a huge thing. Data can be leveraged for good, and that's something that we truly do believe in at Geotab.
Mike, what's the best way for people to learn more about Geotab? Is it the website?
Yeah. If you go to the website, geotab.com, we've also got data.geotab.com, which is the my division's area. And on there, we've actually got a whole whackload of freely available public data sets as well, too, that you can access. So if you're looking at developing that next app that leverages some intelligent transportation information, go to data.geotab.com, sign up for an account, and you get access to some really cool aggregate level data.
Awesome. Well, Mike, thanks so much. I really appreciate it. This was extremely helpful, and I think our audience will find it beneficial.
Thank you very much for having me, Rich. It's been a pleasure.
Once again, that was Mike Branch. He's the Vice President of Data and Analytics at Geotab, the global leader in vehicle telematics technology and a company that is on the forefront of the connected car. To stay up to date on our latest podcast episodes, please follow the Drivers Alert Driving Safety podcast page, which is at driversalert.com/driving-safety-podcast. There you will be able to sign up for episode notifications as well as browse our episode archives. And don't forget, the Drivers Alert Driving Safety podcast is the podcast that features some of the most influential people in driving safety. Until next time, please drive safely.